Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today we will continue to learn about how to wiring Pt-100 or RTD sensors to PLC S7-200 Smart CPU SR30 with the analog module EMAM03. So if we would like to talk about EMAM03, there are two inputs of analog and one output of analog also. Okay, so totally three analog, two for analog input and one channel for analog output. Okay, and here is the address AIW16 for analog input channel number 1, and AIW18 is analog input for channel number 2. Okay, and I will use the sensor PT100 or RTD connect to the RS transmitter, temperature transmitter that convert from ohm to milliamp. Okay, so in this section I will use two sensors connect to the temperature transmitter RS3630230H and then connect to the analog of PLC. Okay, so here is the converter, convert from 2Y transmitter to 4Y, yes, and then connect to the PLC. Because PLC is 4Y and transmitter is 2Y, so we need to convert for from 2Y signal to 4Y. Okay, and I will use TIA Portal version 17 and Step 7 MicroWin Smart version 2.5 to create the scale and create the logic to show the status of the sensor. Okay, so before go to create the project of TIA Portal and Simatic Step 7 MicroWin Smart, I would like to detail about how to wiring. Yes, so for sensor number 1 we have like this. We have sensor, right? So sensor, the two wire is connect together, and then we can connect to like this, connect to this terminal of temperature transmitter, and one more core we can connect to this terminal, and we have power supply 220 AC convert to 24 volt DC, and then connect to terminal number 9. Number 9 is plus and number 10 is minus, and we have terminal number 1, number 2 and number 3, so I will use number 2 and number 3. Number 2 is minus, number 3 is plus, so we can connect to supply the temperature transmitter, and then we will connect the terminal number 5 from the converter. Number 5 is plus, number 6 is minus, to the PLC S7-200 Smart, yes, analog module here, connect here. So the signal from the converter is 4 to 20 milliamp. Then we need to convert the scale, right? We need to create the scale. I will detail when we create the program. And for the sensor number 2, there is the same way that we can connect, but we just change this one, connect to analog input channel number 2, so AIW18, yes. So the way of connection is the same, so we can follow this step. It's very easy to wiring. Yes. Okay, so let's go to create the scale. Yes. Okay, so right now I will use two software together. The first one is Step 7 MicroWin Smart. The second one is TIA Portal for show the signal of temperature sensor. Okay, degree Celsius. So first let's open the Step 7 MicroWin Smart. And then we need to set up the hardware configuration, right? Because we use the analog module EMAM03. Yes, so we need to set up the hardware configuration. Okay, so first let's go to double click CPU SR30. If everyone use other CPU, example ST60 or something, so we can choose the same as our hardware. It means that the same as the real PLC that we use. So for me, I use SR30, so I select SR30 and then go to start up. Here is very important. If we choose like this, it means that when we turn off and turn on the power again, the CPU will not run, right? So I will select to run. And then we can insert SB for slot number 1. I will choose battery. And EM0, I will use EMAM03 here. It is 2 AI and 1 AO. It means that 2 channels of analog input and 1 channel for analog output. Okay. So the address will start from AIW16 for analog input, and analog output it will start from AQW16. Okay. So 2 channel it will count AIW16 and AIW18. Okay. So the same as I put here. The channel number 1 is AIW16, sorry, and the channel number 2 is AIW18 used for sensor number 2. Okay. Then here we can configure the mode. So the input we have 2 channels, right? Channel number 0 and channel number 1. So I will use current, yes, because right now we use current. And here has only 0 to 20 milliamp, yes. But the temperature transmitter and converter is 4 to 20 milliamp, yes. So we need to create the scale. And for channel number 1, I will use 0 to 20 milliamp or so, yes. And if everyone would like to use the analog output, we can use also, yes. Example, select with current, select with volt, yeah. I will select volt, yes. Sorry, current also. So this is very important. If we select wrong selection, we cannot measure the temperature, right? Okay, so it's very important for hardware configuration. And then click OK, yes. And we can save the project. I will create a new folder. Pt-100 with PLC S7-200 Smart, right? So example project. Yes. and we need to convert, right? We need to convert the scaling. Yes, so before convert the scaling, I will show the status of the temperature right now. Yes, I will show only raw data, so it is integer, right? So I will insert the integer convert to double integer. So the channel number 1 is AIW16, example VD20, and we need to put the always on, right? And for channel number 2, so we just test the point or test the analog input first before create the scaling. So this one example AIW18, yeah, it is channel number 2, right? VD30, yeah, example, and then we can save and then compile the project. There is no error, right? So we can download. Before download, we can scan the IP address of the PLC, right? Because we use LAN cable connect from our PC to the Profinet port of the PLC. Yeah, so we can scan. Okay, right now we cannot scan, right? So we need to put the IP address of our computer. Yes, so right now I use Visual Machine. So I use select to this mode, and then I will scan again. Okay, so right now it detects one CPU that has IP address 192.168.0.2, and then we can put our computer IP address to be the same as the rank of the PLC. So I will put 192.168.0.253, subnet mask 255, 255 and 255.0, right? And then we can click OK to download. Yes, and then we can online. So right now the analog input has raw data. Yes, raw data around 11,000. Yes, the same as the condition, because right now I already connected the sensor to the converter and connect from the converter to the analog. Yes, so it shows raw data like this. Then we can convert the rank from this raw data to the actual temperature, right? So I have one formula, yeah, here. So output equal input minus low scale input. It means that input, it means that this one, yes, minus low scale in, and then multiply by high scale out minus low scale out, and all this I will divide by high scale in. It means that high scale input minus low scale input, and all this one I will add by low scale output, right? So it is the same as here. Yeah, I will press F1. Yeah, and then explain here. So we can search scale. There are scale integer to real, real to integer, real to real, right? So first we need to convert from integer to real, right? So double click here. We will found the formula here. Yes, the same as my formula. So the output is out, variable type is out, and the data type is real. So the input is in and integer. Yes, so input is integer here. Here is integer. Then OSH, it means that real. Yes, input 2. And definition here, scale output value, analog input value. Yes, and for OSH, it means that real data type, high limit of scale of the scale output value. And OSL, it means that low limit of scale for scale output value. Yes, so we can copy this formula to use. Yeah, because if we install the software step 7 MicroWin Smart, we will got like this. So we just press the F1 on keyboard. Yes, and then search scale, and then double click scale integer to real. We will got this formula. Okay, so we can use this formula. Okay, so I will copy this formula to our project. Okay, so this one I will delete first because we already test the analog signal. And then pass the formula here. Yes, so we need to create the variable, right? Parameter input and output, the same as the head, right? Here we have totally 1 2 3 4 5 input and 1 output, right? And the data type we have real and integer, right? Okay, so we can follow this formula. Actually we can copy to use. Yes, so let's go to create the variable. So let's go to SBR0. Yes, and then we will create the input and output, right, for parameters. Yes, let's see the help for detail here. Yes, the purpose of this subroutine, yeah, to scale integer number from input range to real in the output range, right? So first here it already detailed. Yes, the software already detailed for us. So we need to insert the parameter. Yes, so the first one I will insert the parameter input. So we have input, right? So input, it is the real, right? Input integer, the data type is integer, so we can copy command, yes, analog input value, and we have OS8, right? So OS8, it is the real, right? For data type, it is the real, so we choose real. And for description, we can copy here. Maybe I will put like this. And I will put our project like this, easy to copy. Okay, paste. And next, OSL, right? It is the real also for data type, so we can choose real. And the description is low limit of scale for the scale output value, so we can copy and paste here. Next, ISH, right? So ISH, it is the integer. And then we can copy the description and then paste here. And next is ISL, so ISL, it is integer also. Then we can copy the command, yes, and then paste here. And we have output, right? So output, so we put here output, and the data type is real. Description is scale output value, yes. And then we can follow this formula. So the first one, we can use the always on, right? So double click and then always on. And we can use sub, right? Sub real. So I will zoom a little bit. So we have sub real. So sub between OSH, so we can type OSH and OSL, right? And we got OSH. and then we can sub integer. So sub integer, yes, and we can connect. So sub input, so input ISL, yes, this one, and then this one input, and the next we can convert from integer to double integer, yes. So integer, converter, right? Convert from integer to double integer. Yes. And then convert from input to create the temporary. Yes. I will create the temporary here. It is the temp D, right? Temp underscore D. It is the double integer. Yes. So here I can do temp D. And the next step we can follow by this formula. Double integer to real, right? So convert from double integer to real. Yes, drag and drop. And then convert from temp D. So temp D convert to temp R, right? So I will insert one more temp. Temp R. It is the real, right? Data type should be real. So temp R. And then we must multiply by OSH, right? So multiply real. So go to plotting math, multiply real, and then multiply by temp air with the OSH, right? OSH, yes. So we can check sub real, yes. Subtract integer, convert from integer to double integer, convert from double integer to real, and then multiply by high scale out, right? And then we can continue to network 2. So I will insert all the way on, and then sub integer, right? So sub integer, go to mathematics, sub integer, sub the ISH by ISL, ISL, and then equal ISH. and then convert from integer to double integer, right? So convert from integer to double integer. Convert ISH, convert to temp-d, and then divide real. So double integer to real, yes. Double integer to real, and convert from temp-d to temp-r, and then divide real. Divide real, right? So go to divide real. So divide by OSH with the temp-r, and then OSH, and next add real, right? So add real. So add between OSL and OSH equal OSH, and the last one move real, right? The last step is move real. So go to move and then move real. So move OSH to output. Okay, so that's all for create the scale. Yes, and if we would like to use this scale, we can go to the main program and then insert the always on, and we can call the block to use. Sorry, this one should be create on int o, right? So I will copy this network. I will copy this parameter. I will insert the new subroutine and then rename to be actually we can call this one to use. Yes, no need to create the new. So we can call this one to use. So we will got like this. So first we need to put the input, right? So AIW16, yes. And we have high scale output, right? High scale output. So let's see here. I have high scale input, low scale input, high scale output, and low scale output, right? So high scale output is 100 degrees Celsius. So I will put 100.0 and low scale out 0.0, and input high scale I will put the maximum of the analog input range. Yes, so 27648, and then low it will around 5550, because I already test with the standard source 500, sorry, 5550. And then for output I will use, it is real, right? I will use MD40 or MD10. Yes, we can compile. So we have some error, right? Total error 28. The row 1, oh, this one should be deleted, right? No need to use. Okay, we try to compile the program again. So there is no error, right? Then we can download to the PLC, and then we can start the PLC and online. Yes, so right now the temperature around 27 degrees Celsius. Yes, so I will hit the temperature sensor, and then let's see the result. Yes, I will hit the sensor number 1. Let's see, the temperature is increased to 65 degrees Celsius. Yes, so that's correct. And then if we want to use the sensor number 2, yes, we can use also. So we try to copy here, and then we use the always on, and just change this one to be AI W18, right? Okay, no error occur. And then change this one to be MD20. Yes, and try to download. Okay, let's see, the value is changed between temperature sensor number 1 and number 2. So I will hit both sensor. Let's see, the temperature is go increase together because I hit both sensor. Yes. So the formula that we created is correct. Yes. We can also simulation on Excel. Yes. Because the formula is the same. Let's see here, 16014, so around 47, 45, yes, here. So the formula is correct, yes. And then we need to show the signal of temperature on the HMI, right? So we can go to TIA Portal. So wait a moment for open the TIA Portal software, and then go to create the new project. So I will put the project name PLC S7-200 Smart with sensor. Yes. And then go to the folder. I will put on the folder that we already created here. Yes. And then click create. So wait a moment for create the project of TIA Portal. And then go to project view. And we need to create the new device, right? So double click on new device. And then go to add the HMI. Yes. Because we need to show the HMI, so the status, the actual temperature on HMI, right? So I will use this model. Yes. So take time a little bit more to create the device. Okay, just click finish. Okay, I will delete all this one, and then we will put the label, right? Connect temperature sensor to PLC Smart S7-200 Smart. I will put the rectangle like this, and then change the background of screen to be this color and this color also. And I will change this one to be yellow. Yes. And for the layout, I will uncheck the fit object, yes, to adjust. So first, let's go to create the connection. Yes. I will insert the new connection. Example PLC Smart. And the driver communication is S7-200, right? And then I will use the Ethernet because we connect using the LAN cable from our PC to the Profinet port of PLC, right? So 192.168.253, it is the address of my PC. and the PLC is 192.168.0.2 here. Yes, so I will change from 1 to 2 and go to create the text, right? So let's go to HMI text and create the text, and the text is MD10 and MD20. Yes, so MD10 sensor 1, it is the real, right? And I will use the connection with the PLC and change the address to be VD10, right? Sorry, MD10. It is the sensor 1, right? 100 millisecond. And for sensor number 2, I will use real also, and MD20. Yes, it is the address of sensor number 2. Yes, MD20. And then we can go to the screen and we can drag and drop the text. Sensor 1, sensor 2. Yes, and then save, and we can compile the screen. There is no error, right? Good. And then I will put sensor 1 here. And sensor 2 here. Yes, and the data type is degree Celsius, right? So degree Celsius, okay, and then we can group. So the data type is degree Celsius. And then we can modify the option to be 999.99, and it is the output only, right? So output, and for this one also go to property and change to be 999.99 and change to be output only. Yes, and then we can adjust for the alignment to be text format. It should be central and middle. Yes, okay, and then we can simulation, but before simulation let's go to cross check the control panel. Go to set PC interface 32 bits and make sure we select the S7 online here. Yes, otherwise the simulation is not work. yes, and choose the network that we already connected, right? And then we can go to simulation. Okay, we got the actual temperature here. So the screen, I will adjust the screen a little bit. This one should be center, right? Okay, and then we can save and then simulation again. Yes, because I just adjust the size a little bit. Okay. So let's see here. Sensor 1 around 27 degrees Celsius and sensor 2 around 28 degrees Celsius. So I will hit the sensor again and let's see the result. I will hit together. Let's see the temperature will go up very fast. I hit until 100 degrees Celsius. Yes, 109. Yes. So it over limit, right? It will go down. Yes. So this is just a sample about how to wiring the PT-100 or RTD connect to analog module of PLC S7-200 Smart model EMAM03. Yes, and how to create the scaling to convert from the raw data to the actual temperature. Yes. So actually we can follow the hell if we would like to create anything. We can follow the hell. Just press F1 and then see the instruction. So we can do it. Okay. So thank you very much for watching my video. And if everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to request all of you to like, share, and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time I would like to say thank you very much again and see you next videos. Bye bye.